Hello and welcome to this video about matrix proofs. In this video we'll be studying proofs about similar matrices. We'll use this symbol to denote the similar matrix symbol, which is a sine wave in the HTML character set. I wanted it to look different to the row equivalence relation symbol. I gave it a different color too. So in the first part of this proof we'll prove that matrix similarity is an equivalence relation. Then part B of this proof says that if two matrices are similar, then their determinants are equal. The determinant proofs will be studied in a separate playlist, since there'll be 10 or more videos about them. And then finally, we'll prove that if two matrices are similar, then their traces are equal. We've already proven this in the previous video. And this is the definition of matrix similarity. There will be a matrix P that will multiply on matrix B like this to give matrix A. This sort of multiplication is called conjugation. So now to prove part A, that matrix similarity is an equivalence relation. This is done by showing these three things, that it's reflexive, symmetric, and transitive. Now to show that this relation is reflexive, that is, that a matrix is always similar to itself. We have to get it into a form of being conjugated by another matrix to get it back unchanged. So if we conjugate A by the identity matrix, we'll get A back, which satisfies this property. The identity matrix is obviously its own inverse. Now to prove symmetry, that the order of these matrices about the similarity sign won't make any difference. Since A is similar to B, we can set P to be the conjugation matrix like this. Then we'll perform this multiplication, which is another conjugation. And the inverse matrix pairs cancel around matrix B, leaving B by itself. We can set Q to be the inverse of P like this. And so we've got B in terms of A, so that it's in the form of being similar to A. So matrix similarity is symmetric. Now to show that this relation is transitive, we've got to show in this case that A is similar to C. We can write out these equations like this because these matrices are similar. Then we can make this substitution to get A in terms of C. Then we can apply the property of inverse matrices that we've proven in a past theorem. We can set matrix R to be this, and so the inverse of R is equal to this. We can then make this substitution so that A is in the form of being similar to C. And then we can write this down. A is similar to C. So we've proven transitivity. So matrix similarity is an equivalence relation. Now to prove part B, that if two matrices are similar, then their determinants are equal. I'll prove all of the properties of determinants in a future playlist. So now to prove this, we'll write out A in terms of B. Then we'll take the determinant of both sides. This is a property of determinants. We can split this into the product of three determinants. This is also a property of determinants. We can take the -1 indice outside of the determinant function. And then finally we can cancel out these terms to get the determinant of B, thus completing this part of the proof. We've proven the final part of this proof in a past video called Matrix Proofs 15, where I proved 4 facts about the trace function. I'll just rewrite it out here again for completeness without explaining it. So I hope that you've found this video to be educational and helpful. Please click like and subscribe if you did. Feel free to write anything helpful in the comments and to share this video, and thanks a lot for watching.